difficult problem, 935 night dialer. So we are having a chess table. So this is chessboard, and gonna be the positions of the knight can go. So for example, there will be 8 directions. It can like move 2 squares vertically and 1 square horizontally, or 2 squares horizontally and 1 square vertically. So this is the positions where a knight can move to the next step. And a chess knight can move as indicated in the chess diagram below. But we're going to turn this problem into another problem. It's going to be the knight dialer. So it seems it is inside a dialer. So we're going to press the buttons, but we cannot press the star and hash, but we can press all the numbers. So the knight can only stand on a numeric cell, so all those numeric cells, and we're going to return how many distinct full number of less n. So this means, so for example, if this less n is 1, so we can dial 0, 1 to 9. It's gonna be 10 different combinations. So if it is 2, it can be like 0, 4, 0, 6, because this is a 0, and after 0, we can go to 4 or 6. So we can go to 4 or we can go to 6. So for example, if it is 4, we can go to 3, 0, and 9. So for example, 4, 3, 0, and 9. So according to this kind of information, definitely we can build a graph. So this is going to be an adjacency list. And then we're going to use the graph to solve the problem. After building the adjacency list, this means if we are at number 1, we can go to 6 and 8. If we are at 6 and 8, we can go to 1 and 3. In this way, we can calculate all the different combinations. And as this n gonna be a really big value, and the final result gonna be 10 to the power of 9 plus 7. So in this way, we can use the search to solve the problem. We can use the DFS plus memorization. So it's similar like DP, we can solve the problem. Yeah. So we're gonna define the DFS function, as we already have the adjacency list. So I didn't write the adjacency list because it just takes some time. Normally, I think everyone can write an adjacency list according to the requirement of the problem. Yeah, but basically we need to take care of that 5. So if there's only one step, so we can press this 5. But there are more than one step. So for example, if there are 2 steps, we cannot press 5, because if we press 5, where is the next step? We cannot go anywhere to the next step. So this is my definition of the adjacency list. So I will not include 5 inside. Yeah, because I would have a check. So if this n equal to 1, I'm gonna return a 10 directly. So this is why I didn't put 5 inside. I think this is gonna be easier. Now I want to put the numbers and steps inside my DFS. Yeah, currently I will give a pass, and then I will write the DFS. So I'm gonna check the result. So the result would be sum of all those DFS, because I'm not sure which button I'm gonna press first, maybe 1 or maybe 2. So this is why I'm gonna use a sum of all combinations. Yeah, I think this is also easier for such kind of a problem. And then if I press a button, for example, I press 1, I've already used 1 step. Yeah. So it's gonna be the sum of DFS, I with 0. So from beginning, the step is 0. So for I in range 10, if I not equal to 5. So this is gonna be my result. So this result can modular a mod, and I'm gonna define another variable. It's gonna be the mod. Yeah, it's gonna be 10 to the power of 9 plus 7. So I want to build a basic structure, and then I will just focus on the DFS. Yeah, because definitely this is not a difficult problem. We can solve it. So this is why I will build a full structure to solve it. If it is hard, definitely I will not write so many lines of code, basically. Yeah, because I have no idea of how to solve it. Why I should write so many lines of code. Yeah, it's no use. So the basic structure is that I'm gonna calculate the sum of the result, and then yeah, maybe I will not use a modular. I will just calculate the sum of them, and then the result would modular this mod. Now this is the basic structure. If n equal to 1, we're gonna return 10 immediately. Otherwise, I'm gonna sum of all those. Yeah, because at least it will have 2 steps. So it's gonna be from the first number, it can be 0 or 0 to 9. So 0 to 9. So this is the step. Yeah. Now I will focus on the DFS because it is a memorization. I'm gonna use a cast to memorize it. So the time complexity would be I times this step times 10. So I, let's check, I is 10, and the step is 5,000. So it is 10 times 10 times 5,000. So it is 100 times 5,000. So it's not a big number. So definitely we can solve it. Now I'm gonna check the step. So if this step equal to n minus 1, here we need to take care because here we've already used one step. So that is why here it should be n minus 1. So we're gonna return a solution. Now we're gonna check where the next node I can jump after the first one. Maybe 0, after 0 it's gonna be 4 or 6. So for j in G with I, so I'm gonna have a result plus equal to this DFS, and because I want to sum up all the possible ways, so it's gonna be J and step plus 1, and finally I'm gonna return the result. So the result from beginning should be 0. Yeah. So this is gonna be the whole structure, of this DFS plus memorization. Because we are going to calculate how many different ways. Basically, it's a search problem. We're gonna search in a board. This list should be easier. Now let's just go focus on this part. I think the main part would be this DFS. We just need to check how many different ways. If we reach a destination, it is n minus 1. So we're gonna get a solution. It is 1. Otherwise, so we're gonna check from the 0 to combine all different ways. So finally we're gonna return this result. If we use a modular, it's gonna be a little bit faster. Yeah. Now let me run it to check. As you can see, it works. Now let me submit it to prove it can pass all the testing cases. As you can see, it passed all the testing cases and it's pretty fast. Thank you for watching. See you next time.